So, here I am, the world's meanest teacher, giving you homework over the Christmas break, but you'll survive. Really, not that difficult. We've talked so far about chemical reactions. We know what the products of combustion are going to be. We can predict that quite easily. We know that we can predict the products of a single replacement reaction by knowing which metal is more reactive. If the metal, the metal that is an element, is more reactive than the element in the compound, the element will replace the one in the compound. If it's less reactive, nothing happens. We also have predicted, my pad just fell down. We also have predicted products of double replacement reactions by looking at solubility. If something is insoluble, it will precipitate out and you'll have a reaction. So now we're going to look at decomposition and synthesis reactions. Basically, we classify decomposition based on what we're made of. So starting with an acid, and we'll start with a simple one, carbonic acid. It will decompose into carbon dioxide and water. In fact, there are double replacement reactions where carbonic acid will be made as one of the products, and it will go ahead and decompose because it's not stable into carbon dioxide and water. You can also have an example of nitric acid. Nitric acid will decompose into some kind of nitric oxide. I'm going to use X and Y there just because I don't actually know which particular non-metal oxide, nitric oxide that would be. So we're just going to be generic for now, and water. Okay? Next up, metal hydroxides. We all know hydroxide, of course, is OH. So a metal hydroxide, for instance, magnesium hydroxide, if we decompose that, we're going to get magnesium oxide and water. That would work for anything. We could substitute iron in here, and we would get, can you guess? Iron oxide and water. Pretty spiffy, huh? A metal carbonate. A metal carbonate is going to be something such as, I have to think about one. Well, the obvious one comes to mind. Calcium carbonate. Calcium carbonate is chalk. Okay? Calcium carbonate will decompose into calcium oxide and carbon dioxide. Again, that carbonate likes to become carbon dioxide. A metal chlorate, such as, what shall we use? How about strontium chlorate, will decompose into the metal chloride and oxygen gas. So we have strontium chloride and oxygen gas. A metal oxide, potassium oxide, say, will decompose into potassium and oxygen. What can we use this information for? Well, if you look at the next page, page 30, here we have 5 compounds. I'll bet you anything if we compare these compounds to the notes we just wrote down, you will find that you can do this. Sodium chlorate, for instance. I'll go back and I'll give you a hint. Sodium chlorate is a metal chlorate. So, you need to fill in 1 through 5. All right, let's go on to synthesis reactions. Synthesis reactions, a little bit more complex. If you have a metal and a non-metal, they will form together to make an ionic compound. The obvious one, sodium and chlorine gas, and I say obvious one because when I've taught this before, that is one I've seen pictures of that I used to have in a slideshow. But it could be any metal and non-metal. You could have, strontium iodide, and it would decompose into strontium, or it would not decompose. Strontium and iodine would synthesize into strontium iodide. There you go. A non-metal oxide plus water. So magnesium oxide plus water will make an acid. How's that going to work? Well, you've got the hydrogen, and the acid is going to be... That's not a nonmetal, Mrs. Bush. Non-metal, it says. A non-metal oxide would be something like nitrogen dioxide and water. This will work a little better. We'll combine to make nitric acid. A metal oxide and water, which is what I was trying to do before, will combine to make a base, a metal hydroxide. Okay? Two nonmetals will become a covalent compound, but you have to know what you're making. So this is an example. If you have nitrogen and hydrogen, you put them under the right conditions, you can make ammonia. Ammonia is a chemical that is used in cleaning. It has a very pungent odor. I think I may have told you guys the story. If I didn't, remind me to tell you the story about the raccoon under the deck, because the way we got it out from under the deck and got Teddy pulled away from there was we threw tennis balls soaked in ammonia underneath the shed, and that eventually drove the raccoon out. All right, let's look at these questions. We already talked about 1 through 5. Here we've got a synthesis reaction, and you're just going to write the equation. All right, and here's a decomposition. You're just going to practice writing the equation. The back page, there's some synthesis reactions. Again, just follow the template that you just took notes on. Metal and non-metal. Let's see. Metal and non-metal are going to make an ionic compound. Calcium plus sulfur will give you calcium sulfide. Okay? So just follow the pattern. This will be due when you get back from school. It's not that hard. I have complete confidence in you. I hope you've had a wonderful break if it's the night before you come back. I hope that you're going to have a wonderful break if it's the first night of break. And if it's somewhere in the middle, have a great rest of your break. Goodbye.